Many people are familiar with a generator like it was inside a flashlight, where if you rotate the flashlight back and forth, this little magnet goes in between the coil of wire and creates enough electrical current to power the flashlight. But what a lot of people don't realize is that when you generate an electrical current, you also create a magnetic field. And what's interesting is that that magnetic field is in the opposite direction of the way the magnet is moving. I can show you that here. This is a rare earth metal magnet. It's called a neodymium magnet, and it's super strong. I'll give you an example. This is a piece of steel, and it's really actually kind of hard to pull off. It's extremely powerful. This is a piece of aluminum. The aluminum is not magnetic, but because it conducts electricity, if I rub the magnet over the top of it, it creates an electrical field that you can't see, and it also creates, that electrical field creates a magnetic field, which you can feel. Now, you can't see what I'm feeling, but if you did this on a piece of aluminum, you'd feel it. But I can show it to you. We have a wooden portion and an aluminum portion, same kind of metal. If we drop it down the wood, watch how fast it goes. If we drop it down the metal, as it slides, it creates an electrical and magnetic field, and it's the opposite of direction as it wants to slide, so it slows it down. Same thing with a spinner. Right here we have a spinner. Watch how slowly it stops. Now we're going to use the super strong magnet, and I'm going to get it really close but not touch the spinner. This is called an eddy current brake. They use these kinds of brakes on electric magnetic trains and roller coasters, power tools when their power is turned off, and utility meters, or electrical meters for utility companies. So here we have two aluminum plates. Again, they're not magnetic, but if we drop the magnet between them, they create an electromagnetic field that's the opposite of the direction it wants to fall, and it falls very slowly. Over here we have a pendulum, and again, this is a non-magnetic plate, and what we'll do is we'll adjust the pendulum so it's just barely above, so it's not touching. You can see as it swings, without it, it swings just normally. If you stick this underneath, if we get it just the right height, it stops it. I think that is just really cool and really weird to watch. And you can actually move it by just moving this. It's not touching still, but it's creating that electromagnetic field. Those eddy currents are just really cool to watch. Now, we've dropped it from a short distance, so one of the things that's really fun to do is drop it from a taller distance. Short drop from about 1.5 feet. But sometimes a long drop is even more impressive. This is a 4-foot PVC pipe, and we have, again, this rare earth neodymium magnet. And if I drop it in the pipe, it drops to the floor very quickly. It takes less than a second. But if we, again, show you that a copper pipe, same height, 4 feet, and we drop it in here, it drops extremely slowly. If you listen carefully, you can hear it scraping on the inside, but it really doesn't want to. So it comes out very, very slowly. Problem is you can't see it. So what I have here is a little piece of tape, that has some iron filings in it. And what we'll do is we'll put this on the outside. There's few enough of them so that it won't stick and make this any slower, but it will show us where it is. So here we go. Ready? That is extremely slow. And that's how eddy currents work.